It's really simple. When you think microservice patterns, you think Chris Richardson. Chris is a very popular and authoritative voice in the microservices space. He runs a website, microservices.io, which is a go to resource for anyone trying to architect microservices and need to learn common patterns. He's also the author of the book, Microservice Patterns. So you can guess what I talked to him about in this interview. At the end of the interview, Chris actually kindly agreed to speak with me another time to answer any of your questions. So, wherever you're watching or listening to this episode, drop your questions on microservices and microservice patterns in the comments, and I'll pick the best ones to ask Chris in a follow up interview. Okay, so without any further ado, here is my interview with Chris Richardson for this episode of The Artifact. A lot of my viewers and my audience are very much into microservices, specifically the Spring Boot microservice development process and the technologies involved. So very excited to have you here and kind of pick your brains about some questions that I have about microservices, echoing some of the questions that my audience has.
Yeah.
It's your name is kind of synonymous with microservice patterns today. It's you're like the leading thinker of microservice patterns. Your website is super popular as my go-to resource as well. But the thing is, I didn't quite know till I researched about you that you have written a book long back that I had read that I didn't even know, I didn't make that connection, which was Pojos in Action. Can you tell me a little bit about how you got to Pojos in Action and what's been your journey to getting into the microservice side of things?
Oh, yeah. I mean, that's kind of an interesting history lesson. I've been an enterprise Java developer for quite a long time. I didn't even know what it was called way back then. I guess it was enterprise Java development, but I suppose, is it like 1998? Something like that.
Wow.
So back then, technologies like enterprise Java Beans 1.0 were popular. Building applications on, certainly by 1999, it was building applications on top of WebLogic, which was a BEA, actually ultimately acquired by Oracle, but that was a super popular and actually super high quality application server. And so sort of my journey was sort of like 2002, 2003. I was the, I guess, chief architect, something like that at this company, and we were building a device management platform. So a server for, actually initially it was doing over-the-air firmware upgrades of mobile phones, which back then seemed like magic. Now we're just sort of used to it. And then it generalized into a device management platform where you could push configuration down into the phones. And we were building it with EJBs and all the classic, stuff from that was, in hindsight, quite terrible.
They were pretty intense, weren't they? Like I remember I got into the EJB2, that was when I made my introduction to the EJB world. And it was like, this is too much. That was the reaction that I had at the time. But yeah.
Yeah, it's interesting. I think, say, we as developers will kind of we'll end up using technologies that, 5 years later just look like a thoroughly stupid idea. Really. I mean, like I remember doing this in the earlier in the 90s with like C++, right? And it's like, yay, every class you'd implement would actually be two classes because one class was like a smart pointer, as the bridge pattern and or envelope and letter. And it was like, yay, we're doing this and it feels good, right?
Yeah.
And then, in hindsight, well, that's just stupid. And then, a few years later, we're doing EJBs. And in hindsight, those were pretty stupid too.
Makes you wonder what we do now, which we consider stupid in 5 years' time. But yeah, sorry, go on. So
yeah, I could make some caustic remarks, but then I'd upset certain language communities.
Oh, wow.
But then I went to the server-side Java Symposium, which, that's another bit of, I think, ancient history. But that was like the conference to go to learn about sort of cutting edge Java technologies, right? The server side and so on. And I spent like, I don't know, 3 days there being immersed in like dependency injection and Spring and AOP and all this super awesome technology. And then I just literally went back to work the following Monday and said, okay, team, we're switching to Spring. And Hibernate. That was the other part of it, right? Because they were, they were clearly simpler, simpler and more powerful than sort of the standard technology that we were working with. And maybe, I can't even remember, maybe we started using Tomcat instead of WebLogic. I mean, it's all a long time ago. And interestingly, at the time, I was actually writing a book about enterprise Java development that was sort of the EJB flavored style of it. And so I just started again and wrote a book about Spring and Hibernate, which basically that's what Pojos in Action came.
Cool.
And yeah, that was like a 4-year writing project.
Wow.
It was like, it was horrible. I mean, if anyone, in the audience is writing a book or has written a book, they just, you think it's just this pleasant process, but it thoroughly sucks to write a book. And that was like my nightmare.
Yeah.
I think I had PTSD after I finished it, actually. I couldn't even bring myself to open the book.
Oh my goodness.
It just generated anxiety.
It is a lot of hard work. It's seems very deceptive in the beginning when you come up with an idea and come up with, okay, these are the chapters. Like, how hard can it be? You already know the topic. You're just putting it into words. But then once you get into it, it's pretty hard work. Can you tell me about your how you got into the microservices and specifically the microservice patterns side of things? What?
Yeah. Yeah, I suppose then so that was sort of my Pojo thing. And then later on I discovered AWS. Because I think part of the journey involved the cloud, right? And so 2006, when AWS was like, no one knew about it, an evangelist showed up at my local Java users group that I was running. And we thought he was going to talk about APIs for buying books, but instead he talked about EC2, S3, SQS,
Yeah.
So that sort of then led me to create the original Cloud Foundry. So PaaS for deploying Java applications on EC2. And yeah, so I did that. And then maybe it was around 2010, I read this book, The Art of Scalability. And I should say all the applications I built up until this point were just monoliths, right? Because that was the way you built them. Beginning of the project, make dir, the app, just type in code. But then this book actually has this concept of a scale cube that's a 3-dimensional model of scalability. And one way of scaling is x-axis scaling, which is where you run multiple copies of an application behind a load balance. So that's the normal way of scaling. But y-axis scaling is functional decomposition. And it's sort of pointing out an obvious thing. Well, you can break your application into parts, which in hindsight, it's like, duh. You know what I mean? It was sort of such an obvious point. Obviously, it's sort of, there's some non-trivial issues involved. But then when I sort of look back in hindsight at the original Cloud Foundry, which had been constructed as a monolith, if we had built it as a distributed system, it would have been, even though we were a team of 2, it would have been a much better architecture and would have solved a whole bunch of development and operational problems.
Yeah.
So it was sort of like, oh yeah, I had this problem. Then I discovered this obvious solution of basically services. And it just sort of heavily resonated. By this stage, I was actually VMware because Spring Source acquired Cloud Foundry, which was then acquired by VMware.
Yeah, yeah.
And then they took the name, built a new Cloud Foundry, and I ended up being part of the developer relations team for the new Cloud Foundry. And I started giving talks on the microservice architecture, even though that wasn't what it was called. I was talking about modular polyglot applications for improved deployability and testability.
Wow. Why that name didn't catch on.
Yeah, I need to work on my naming.
But that's amazing that you're kind of at the forefront of this thing. That's amazing.
Well, yeah, but not exactly, right? I mean, I started making noise about it, and I started giving. Well, what happened was, in 2012, I started giving talks all around the world. That was my job, right? And I talked about how modular polyglot applications were a perfect fit for Cloud Foundry, and it really resonated with people. And so it's like if you start talking about something and people pay attention, you tend to talk about it more, right? And it's this feedback loop. And got to now, what's this, like 10 years later, I don't think about anything else, right? Which is kind of sad.
Makes sense, yeah.
But to be fair, this is an old idea. If you look at how Amazon's architecture, the original Amazon.com was a monolith. And then in, I think, 2002, so like literally 10 years before I talked about it, they were already doing it. Jeff Bezos sent out a memo and just said, okay, people, you're now doing service-oriented architecture. Teams can only collaborate through APIs and so on. And they did that not because they were operating at sort of massive scale, but because they were in a really competitive domain, namely online bookstore, right? Where they needed to be able to rapidly iterate on features. And then similarly, all these examples were out there, like eBay. I remember going to a talk on their architecture in 2008, roughly, and they went through this architectural evolution from, it was like a C++ monolith to a Java monolith to services, right? So all these ideas are out there. They just take a long time, in some cases, to diffuse through the community. Like William Gibson said, the future is already here, but it's unevenly distributed, right? And I think that is so true.
That's very true. That's how any innovation spreads. So at any point of time, there's somebody doing what is going to be the thing of the future. So it's just about getting that mind share of the people. It's interesting though that you said that this is all you think about and talk about now. How tired are you of the microservices versus monolith question? Which is better? How many times a day do you get that question now, Chris?
Well, what's funny is I guess the people who talk to me, they're interested in the microservice architecture. And I mean, sometimes I even try and talk them out of it because it's most likely not applicable to their particular application. So we're sort of in this microservices anti-hype phase, right? Where if you create a tweet criticizing the microservice architecture, the level of engagement is off the charts, right? Even if it's just making some sort of trivial point. And it's kind of tedious, really, because, right, it's sort of like there are two architectural styles. They have benefits and drawbacks, and in some situations, the monolith is better, and in other situations, the microservice architecture is better. And that's all there is to it. And and any claims to the contrary that monoliths are the future are or microservices of the future they're sort of equally misguided, right? I mean, in a given situation, it's like stopped clock, right? Stopped clock is right twice a day. They might happen to be right in a given situation, but it's purely coincidence more than rational decision-making process.
Right. It's also a pattern in itself, isn't it? You can kind of think, you talk about so many microservice patterns. The microservice approach itself is a kind of an Uber pattern, and taking a monolithic approach is another pattern to solving the problem. Don't you think so? Again, each of those comes with its pros and cons.
Yeah, I mean, there's sort of obvious distinctions, right? Like a distributed system at some level is more complex than a non-distributed system because of all of the issues around, like potential runtime coupling, the inability to use ACID transactions across services, right? So it's sort of more complex. But on the other hand, a large monolith is, if you need to be able to develop and test and deploy very rapidly, right? You've got a large team of developers who are committing many times a day, and you want to have a fast deployment pipeline. That can be quite challenging to achieve with a monolithic architecture, right? Or, even more trivial examples. I mean, it's quite common in an application to need to use multiple technology stacks, right? Like majority of your application is written in Java, but then some of it is written in Python, right? And you need to run it using the Python runtime because of some machine learning libraries or something like that. Or you need something written in Rust for whatever reason, or Golang, right? Then inherently you have a distributed architecture at that point. It's kind of a simple one, but technology concerns can force you in that direction. Another aspect of technology is you need to be able to evolve your application's technology stack over time, keep it current so you can apply security patches easily. And yeah, if you've got a massive monolithic code base, I would argue it's really difficult to schedule the large upgrade effort. Because it's a large task that has to be done, in one go. Whereas in a microservice architecture, you can upgrade one service at a time. You break the upgrade task into a series of small subtasks that can be, I think, arguably a lot easier to schedule. And given that, a lot of applications, pretty much successful ones, often live for basically forever.
Yeah. At least
and you got to keep them current. You got to be able to replace parts of them over time.
Yeah. So, that's one thing I like about patterns is that, a pattern comes with, you take any pattern and comes with, okay, here are the benefits of the pattern. And here are the problems that you are going to have, right? No pattern is a silver bullet. So when you take up a pattern, you have some costs associated with it. And that's a part of a good pattern definition. So what do you think about, like, let's say somebody, opts into the microservices way and there are costs to them. They're in a monolith. They find these problems and they go, okay, we're going to go microservices. And then they go there, they find some challenges there. They apply some patterns to solve that problem. They get more challenges and so on. Is there at any point of time where, someone goes, okay, are we in a worse off position now with the microservices than we were with the monolith? Is there a good time for somebody to kind of do that check? Because, okay, we are so much knee deep in this thing. We are having all these challenges. Did we anticipate these challenges and we took that on as the cost of that initial transition? Or is this something entirely new and we need to reassess?
I would say, yeah. I mean, that it's possible that you could go down the microservices route, and I guess in theory, you could have an application that is just simply not a good fit for the microservice architecture. I don't know. It's unclear at least in theory, right? I mean, you could argue that maybe you've got a latency sensitive application where you can't incur the cost of distributed communication, right? I mean, that might be one reason. You can certainly go down the microservice route and do it badly.
Yeah.
Sort of one of the key defining characteristics of the microservice architecture is that services should be loosely coupled, both from there's a runtime perspective, right? Because that's related to availability and latency. But then there's also design time coupling. So where and this is a fundamental property of software. Your software should be loosely coupled, made up of loosely coupled parts from a design time perspective, where you ought to be able to change one part of your system without having to change other parts of your system in lockstep. And that's all about modularity and encapsulation and defining the right boundaries with stable APIs that encapsulate their implementation. And that's true with say, if you're even designing a class, right? I mean, this is at every level of your design hierarchy, whether it's a class, a package, a module, or a service or an application, you need modularity and encapsulation. The highest level case, right? If you're exposing an API to the outside world, that has to be stable. Otherwise, your customers will hate you. And at the microservice level, I think a common anti-pattern is it's a distributed monolith where you build a bunch of services that are tightly coupled from a design time perspective, such that you keep changing you have to change multiple services in lockstep. And it was funny, there's a company who gave a talk at a conference about how we tried microservices and failed, or I don't know, actually maybe it was more like how we tried microservices and they suck, so we went back to a monolith because they obviously didn't fail. They wouldn't admit to it. But in reality, they had built a tightly coupled set of services. I think there was like a shared library in each one that was constantly changing. So they had to keep keeping them upgraded and on the same version of that library. And I don't think maybe they hadn't implemented the build infrastructure to automate the process fully either. So this is one of the big challenges with the microservice architecture is you could say that, I mean, with any software, it's really important to have design skills, right? But sadly, you could say that not every team does. But in a monolithic architecture, you can kind of get away with it because the cost of a lack of modularity is perhaps lower, right? Whereas in a microservice architecture, the costs are super high.
And the cost feeds into runtime as well. I feel like with, modularity for a monolith is basically during development time, but here it's shared, right? So it's going to take longer to build, and it's also going to affect performance at runtime.
Yeah. So it's very unforgiving, and I feel like, so in order to adopt the microservice architecture, you really have to kind of upgrade your design skills as an organization.
Yeah.
The other aspect is the worst case scenario, right, is you have a bunch of design time coupled services that are, that impacts productivity. And then if they're coupled from a runtime perspective, for example, you just heavily rely on synchronous communication, right? So request comes in, it goes to service A, to B, to C, to D, and so on and so forth, right? Each and every one, if that's all synchronous, every one of the services in that chain is a point of failure. And so we're not only going to have higher latency just because of all of the overhead, but there is a risk of lower availability as well.
Right.
So you build this, you're unproductive and you're building a fragile system.
Yeah, that's rough. Would you say though that if you have a sense for whether a particular problem or a particular application is fit for using microservices, then you can reliably make that assessment upfront and not have it dependent on, your journey down the line, right? How reliable do you think a typical assessment is if done right?
Well, I think up front, right? I mean, there are some criteria. I mean, for the most part, your application should be large, complex. Your team should be large. Whatever any of those words mean, there's some vagueness there, right? In terms of what those words mean. And it should be an application that is, say, critical to your business. Because certainly software that's not critical to your business, you should probably just throw away and replace with, and you should buy it instead of build it anyway, right? In domain-driven design terminology, it's most likely part of your core domain. It's what's giving you a competitive advantage. And then on top of that, it's something that you need to just rapidly iterate on. So you want to be employing, basically DevOps practices, and, which includes continuous delivery. Like ideally, a good end state, right, which I think is quite hard to achieve. Every developer is committing to the main or master trunk every day. And each one of those changes is just automatically being built, tested, and deployed into production. That's sort of you could say, state-of-the-art practice, right? And that's what organizations should strive towards, because if you look at the book Accelerate, it's a really good book, and it's sort of a lot of the kind of the principles underlying DevOps, where they've surveyed lots of organizations and come up with a definition of what a high-performing organization is, which is basically low lead time, time from commit to deploy, high deployment frequency, and how that actually that actually correlates with better business success. So if you want to be successful in today's crazy world, then you need to have a high-performing organization with a very fast deployment pipeline and practicing continuous delivery/deployment.
Yeah, that makes sense. What do you think is the hardest problem when somebody does go to microservices? The common thing that comes up is state, right? So usually when you split a bunch of services and they're all stateless, you usually end up having an okay time managing it. It's only when it comes to like a database where you have data that kind of indirectly couples these services, and that's where problems start. It's like, how do you split the database? How do you ensure transactions happen? Is that the harder? Is that among the hardest problems that you've seen in microservices, or do you think there is something else?
Well, I think number one, it's drawing your service boundaries correctly so that your services are loosely coupled. And in every sense of the word. So certainly from a design time perspective and also from a runtime perspective. And the database part of it, which is sort of the model, right, is that each service should have its own, I'm going to say database schema, right? Its own, a table, or if you take it down to this very fine grained, each table in your database should be owned by a single service, which is the only service that has access to it. Because if you have shared tables, then that's tight design time coupling, which then defeats the purpose of using the microservice architecture, right?
Yeah.
So part of the challenge is splitting your code, but then the other part of the challenge is splitting the database as well. And then that then opens up the possibility. And then there is an issue where maybe you're going to use multiple database servers, which actually is preferable because it further decouples the services from one another, because otherwise they're actually competing for the same resources. And so you could potentially get into, it's a sort of a flavor of runtime coupling where one service could starve other services of the database resources that they need. You know, it's this sort of like runtime coupling / infrastructure coupling. But in general, you then have a situation where some system operations span multiple services and potentially multiple databases, and then you get into transaction management issues. So, which in a sense is you know, you could say that's problem number one is service boundaries, and then problem number two is solving the distributed data management problems that you've now created for yourself. In particular, you know, if you do have a transaction that or a command that spans multiple services, in theory you could use two-phase commit, but two-phase commit is basically well, there's a whole bunch of complexities, and there's a runtime coupling in there as well. Like that command cannot succeed unless all of the participants are available, so it's arguably quite brittle. So a better solution in general is to use the saga pattern, where you have a sequence of local transactions that are coordinated, say, systems I build by the exchange of messages.
What do you think about event sourcing? That's kind of taken some popularity. I mean, these days, is that a good way to manage state and manage this shared data?
Well, it's funny you should say that. So if you go look at my thinking back in 2016,
Okay.
right, 6 years ago, my model of microservice architecture was you have a bunch of services, each one is persisting its business entities or aggregates using event sourcing.
Okay.
Which is basically persisting each aggregate as a series of events in the database. And the reason that was appealing was in order to implement sagas, right, a series of local transactions coordinated through the exchange of messages, a service needs to be able to update its database, create an order, and then publish an order created event atomically, right? Both of those things must happen, or neither of them must happen, right? And event sourcing happens to give you that desired behavior, right?
Yeah.
So the example would be that the customer service would receive the order created event, reserve credit for the order, publish a customer credit reserved event, which would then trigger an update back in the order service, right? So event sourcing was this sort of just natural way of publishing events whenever the database changed, which would then be used to implement these sagas. And to me, if you were to ask me back in 2016, I would have said, it's the one true way, yay. But I guess I have moved away from that.
That's why.
Because, well, part of it was like working with clients who wanted to adopt microservices, but then sort of asking them to adopt event sourcing, which is a radically different way of structuring your database, right? Which actually has some significant downsides as well. Like, for example, your entities are no longer queryable in any, except basically, or the only kind of query you can do on an event store is a primary key-based lookup of a given business entity, right? So all of the regular queries that you'd want to run can't be implemented, and then you have to use a CQRS pattern to maintain a replica or projection of the data. It turns out, I mean, talk with clients and it's like, oh, that's too complicated. In reality, they're actually, those two concepts are quite decoupled from one another. And so in particular, it was like, oh yeah, there are other ways of reliably publishing events, right? Like if we just want to have an event-based sort of architecture, instead of using event sourcing to publish events when the database changes, you can use the transaction outbox pattern, which writes the event to the database, well, update, like creates or updates an order, and as part of the same transaction, writes the event that you want to publish to the database. So you've got atomicity of that. And then there's a separate process that's pulling events out of that outbox table and publishing them to the message broker. So that was like, oh yeah, there's another way of doing it. So you can go have a radically different persistence model, namely event sourcing, or you can use regular JPA or whatever your favorite tools are for persistence with the transaction outbox pattern. So that was a big revelation.
Yeah, if I understand you right, you still think that event sourcing is a good idea. It is just that it's too much of a change for an organization who's already considering a move from monoliths to microservices.
Well, I mean, it's like it's yet another technology which has benefits and drawbacks.
Yeah.
So if it works for you, if it's a good fit for your particular application, sure. For me, it's sort of, I don't really, it's funny because at the same time I was thinking in this way, I created some open source frameworks.
Okay.
And so one of the frameworks I have is Eventuate Local, which is an event sourcing framework. And in particular, I guess one of the notable things about it is that it's built on open source technologies, namely MySQL and Kafka, so that it's like not reinventing a storage engine and a message broker, just leveraging these high quality open source projects. And that was sort of my first attempt at sort of making it easier for people like my clients to adopt microservices, because it was like, you can still use a relational database.
Right.
You just to store it, you just have a different schema, right? So I have that framework, which is still maintaining. But then I created a second framework, Eventuate Tram, as in transactional messaging, which is all centered around the transactional outbox pattern. And, and I guess there are people who are using Eventuate Local for event sourcing, and then there are people who are using Eventuate Tram for, for their services as well. So you can, so it's sort of whatever's really a good fit for your application. I mean, it's very funny. There's actually, I gave a talk at DockerCon, which was like, it was like microservices, event sourcing, and Docker, a match made in heaven. And I think that might have been the most viewed talk that I've ever done.
All right, I'll go check that out. I'm interested in event sourcing. You know what, Chris?
Yeah.
Maybe that could be the thing that picks up 5 years from now, because I see a lot of potential there, but it feels like not a lot of people are open to the idea. I guess it just has to hit mainstream for it to get more adoption. But yeah.
It's interesting. It's certainly in my mind, it was like, yep, one true way, but I just sort of underwent this evolution. And then the other aspect of this, right, is I, at the time, 6 years ago, I thought microservices had to rely heavily on events for, well, basically sagas. And but then I realized that was a specific kind of saga, namely a choreography-based saga, right? And they're powered by events. But then there's an orchestration-based saga that's where there's a centralized orchestrator that is telling the participants what to do. So sort of the final kind of, or more recent evolution in my thinking was, yep, you got sagas. There's two flavors of sagas. choreography-based sagas are powered by events, and there are two different ways of publishing events: event transaction outbox or event sourcing. So I kind of like have been iterating on this sort of conceptual framework over the years.
Interesting. Yeah, I noticed we have very little time left. I want to squeeze in one more question. I listened to quite a few of your talks and really impressed with the way you present this stuff. One thing that really stood out for me was I don't remember which talk it was. You said microservice is basically a partitioning problem, right? And that really resonated with me because that is what we are doing. We are partitioning in terms of domain, we're partitioning in terms of code and all that. Usually the problems we run into with badly designed microservices is, or even with the monolith, is you put two things which shouldn't be together. And at the same time with microservices, you separate two things which should be together. And that's, there are a lot of factors that go into this, depending on the business needs, depending on what patterns you choose and all that. But what I've also noticed is there seems to be this implicit idea in people's minds that, okay, I have a huge monolith. If it goes to microservices, well, it has to be like, 20 microservices or 30 only then it is truly a microservice architecture. What do you think about the stance where you go, like, let's say I have a monolith and I feel like, okay, I just split it into two pieces and I get all the benefits of what I really need, right? So I would never want to be able to deploy both. Like I have independence, I have autonomy for the team, and this serves the purpose. So technically it isn't quite microservices. You basically have two smaller monoliths. Is that something that you would say, well, if that serves your purpose, great? Or are there things to think about? Like,
Yeah.
you know what I'm talking about, right?
Yeah. I mean, so the partitioning concept, right? Yeah, you've got a bunch of subdomains which are team size, well, chunks of code that implement business capabilities. Right. And then picking between the architectures is figuring out how to partition those subdomains to form, shall we say, components, executable, deployable units, right? And if you end up with one partition, you have a monolith. If you have more than one, then arguably you have a microservice architecture, right? Yeah. So it's either one or more than one. Okay. Very binary decision. Yeah, I mean, number one goal of architecture really is to sort of satisfy your non-functional requirements. Whatever arrangement does that is good. Right. And you shouldn't get into philosophical debates about what a true, like, oh, we must have lots of little services in order for it to be considered a microservice architecture. It's just sort of not helpful. So like, one extreme example is, you could have a large monolith, right? And maybe you have a problem of some kind, right? Like, oh, we need to rapidly iterate on, like, I'm going to make up an example, but let's just imagine that there's one particular business capability from which you derive most of your business's competitive advantage, right? So a relatively small part of the monolith. Well, so maybe you just extract out that one small part. So maybe you've got massive monolith and just one relatively small service, right? That then lets you rapidly iterate on that part of your system in order to improve your competitiveness, right? So, I mean, make up an example, but imagine you're a company like DoorDash, right? And maybe the hard part of being DoorDash is scheduling couriers, right? Which is probably a relatively small part of the code base. I don't know, but it feels like, the application does a million different things, but you've got this really complex, tricky scheduling algorithm, right? So, if it's embedded inside this massive monolith, then, oh yeah, maybe you can deploy it once a month, right? Which means that you can only iterate extremely slowly. and it's just sort of all painful. Whereas if you extract it out into its own service, you could iterate on it many times a day. And so, yeah, you've got in a sense, you've got two services, one giant monolith and one relatively small service. And if that works for you and solves your business problem, then that's a success.
Yeah. Yeah, absolutely. I think that's a very important thing to remember, because people kind of go into this with this vision of what their architecture should be. All right, we're going to have so many services. You're going to have the service discovery here. You're going to have all these different, distributed logging, tracing, your fault tolerance, and all that stuff. But the reality is, the more services you have, the more the problems there are, and the more things you're going to have to add on to it to make those problems go away, or at least to reduce.
Yeah. Yeah, you don't win an award for having more services.
Yeah.
I mean, interestingly, I have worked with a couple of clients where at a high level in the organization, they had decided, we're going to do microservices. And what that boiled down to was that engineers had KPIs for doing microservices.
Wow.
So they're literally, their bonus was dependent on doing microservices, whether it was useful or not, right? I mean, that's like an extreme case, but that really did happen.
Yeah.
Whereas in reality, sort of first and foremost, your job as as a developer is to create software that solves business problems, right?
Yeah.
And number one, and then sort of concretely, you could say that if you're measuring things like lead time from commit to deploy, measuring deployment frequency, or measuring some scalability or reliability aspects of your application, success is optimizing those metrics. And if you refactor your architecture just enough to solve problems with those metrics, then you have been successful.
Yeah.
And it might not involve creating a lot of services, right? And certainly in the terms of like, how do you migrate a monolith to a microservice architecture, you are doing it one service at a time.
Yeah.
And you should be at each iteration of the refactoring process, you should be extracting the service that kind of gives you the greatest improvement.
Yeah.
So there's this sort of iterative process where you're getting more and more services, but at any point in time, you might decide to stop because you've solved whatever problems you have, or maybe there's just higher priorities from the business in terms of feature development.
Yeah. So at that point, when you have diminishing returns, stop. Don't just start out with this grandiose plan of what your microservice architecture should be. Right.
Well, I think interestingly, it is good, I think, to actually at the beginning of any migration effort, brainstorm what you think your ideal architecture should be, so that you sort of know what direction you have a direction to head in, right?
Yeah.
But at the same time, it's a journey, and maybe you might have to change direction at some point because you've learned more, and you know that you can kind of revise your target architecture, right? And then also you might get to a nice place where you just want to hang out. You know what I mean? Well, but more seriously, you have achieved your business goals, right? That's good enough.
Yeah.
And so don't feel sad that you haven't fully realized your perfect vision, because that currently is not satisfying the needs of the business right now.
Yeah. There's always other cool stuff to do, isn't it?
Yeah, I don't like the word cool, but it's all about making sure you're and your business is being competitive, right? And winning in the marketplace. That's what's cool.
Yeah. Doing cool that also aligns with the business needs, because that's what our a job is as an engineer. No, I hear that. I hear that. Well,
Yeah.
thank you so much for joining us, Chris. I What I'm going to do is, I don't think I've asked nearly as many the questions that I wanted to ask. I'm also going to give an opportunity to my audience to come up with some questions, and if there are some really good questions, I would love to have you again. Thank you so much for your time. Where
Yeah.
can someone reach you if they want to talk to you, or they want to see what services you offer, or read more about your books and your articles?
Oh yeah, I mean, good place to go is microservices.io.
Yep.
So that's sort of a good starting point. I also have a business website, chrisrichardson.net,
Hmm.
but going to microservices.io is a good sort of, entry point.
Absolutely. If you're a microservices developer and you haven't heard of microservices.io, I mean, what are you even doing? Right? It's a really, no, I'm not being it's really the amount of patterns and the amount of aha moments that I've had on that website is simply amazing. A lot of good stuff on that website, and it's a lot of it
Oh,
available for free. So yeah, definitely recommend people check it out. Thank you so much, Chris. Can't wait to have you again on this podcast. Thanks for speaking with me.
yeah, but thanks for inviting me. It was a good chat.